When work begins, everything is slightly eerie. The only sound is the strange creaking of hundreds of wire cables, pulled as taut as possible, knocking and rubbing against each other in the wind. 1,000 tons of steel hang on the cables, ready to be hoisted more than 100 meters. It's a spectacular event. The huge C3 splitter is slowly raised into the air, with a large area of the site cordoned off and all work stopped. The specialist Italian company, Fioli, has erected a towering gantry to pull the future C3 splitter for the PDH process from the horizontal into the vertical position. This feat involves numerous incalculable factors, such as the strong wind from the Mediterranean blowing towards the desert, strong enough to buffet even a 1,000-ton load, as seen in the time-lapse sequence. Challenges are nothing new for the C3 splitter of the PDH project in Port Said. Originally, the splitter and a deethanizer were to be completely assembled by the manufacturer in South Korea and pushed on a barge up to the beach near the construction site. However, it was impossible to dig out the required navigation channel, as the sea in this area is a designated nature reserve. The C3 splitter is part of the PDH process, with production due to start in a few months. Here, 350,000 tons of propane will be converted into propylene annually and subsequently processed into polypropylene. The transport of the columns called for a new plan. Over the next few days, the deethanizer and the C3 splitter arrive in 6 individual sections, each weighing 250 tons. UDA engineers and specialists from the manufacturer and the transport company discuss the preparation of the foundations. The ship from Korea is already in the harbor. In the middle of the night, the 250-ton Leviathans move through the streets of Port Said. A bridge on the route had to be reinforced beforehand, but the undertaking runs smoothly. A few months later, the 2 columns have been welded together. The deethanizer, now weighing 500 tons and a little over 50 meters long, lies in the background. The C3 splitter, weighing 1,000 tons and 100 meters long, lies in the foreground. Both are still on their sides, being equipped with external ladders, platforms, and insulation. Once these jobs are completed, comes the day of lifting. First, the deethanizer. The gantry has been assembled, but only to half the height required for the C3 splitter. A problem arises as the special follow-up crane planned for the job can't be shipped in time from a construction site in Europe. The alternative is SPMS, self-propelled modular transporters, that follow up the deethanizer as it's hoisted up the gantry. It takes only a few hours before the first column is in place. A few weeks later, it's the C3 splitter's turn. The gantry is now 130 meters high and precisely balanced, held in position by taglines with a force of 200 bars. For this special lifting operation, tension piles made of reinforced concrete have been poured 60 meters deep into the ground. Shortly before lifting starts, a group of surveyors checks once again that the gantry is perfectly straight. A 750-ton crane stands by, its hook picking up the foot of the column. Everything has been precisely calculated. Almost everything. These shackles, with which the enormous steel rope is attached to the splitter, will play an important role.
12 hours later, the crane is pushed to its limit as it lifts the splitter, initially just a few centimeters. The steel supports, which the column had rested on for months, are first cut apart and removed. UDA engineers organize and supervise the entire operation. Finally, the moment arrives. The head of the column is lifted up the gantry. The crane follows centimeter by centimeter. Everything is precisely planned. Nothing is left to chance. Giovanni from Fioli is in charge, issuing orders to his crew as the 1,000-ton Leviathan is raised at approximately 10 meters per hour. Operating 130 meters above ground, 6 men from Podoli ensure the operation doesn't grind to a halt, manually feeding the individual cables onto the pulley. Powerful hydraulic cylinders lift the cables bit by bit, hold them in place, while the pistons slide down again to lift the next section. The whole operation takes 10 hours. The first part of the big lift extends well into the night. Then, a minor miscalculation. When determining the length of the holding rope, the connecting shackles had not been taken into account. The expanding beam strikes the installed platform, and the steel construction has to be demolished to continue the operation. The next morning, part 2 of the spectacular lifting event. The C3 splitter must be lifted another 10 meters and then shifted to the side before it can be lowered onto the prepared platform. Hours of intense concentration lie ahead, particularly in the battle against the wind, which keeps swaying the colossal structure back and forth. Then comes that tense moment that occurs every time such a large column is erected. Will the numerous holes fit over the numerous threaded rods set in concrete? Each one had been individually aligned beforehand in a labor-intensive procedure. The effort proves worthwhile. Everything fits. To begin with, the bolts hold the column in place. Only after the final alignment, the following day, will the C3 splitter be completely released from the gantry. The tension has already eased. It's time to celebrate. Towering over everything around it, the landmark of the PDHPP plant in Port Said is in position. As the sun rises, the site slowly comes back to life. The previous day's tension is replaced with a quiet buzz of activity. Engineers and workers prepare for the next phases of the project, ensuring that every detail is checked and double-checked. The successful lift is a significant achievement, but there is still much to be done. The C3 splitter, now in its final vertical position, will soon begin its crucial role in the PDH process. It will convert propane into propylene, a key raw material for producing polypropylene. This plant in Port Said is set to become a major hub in the region's chemical industry, contributing significantly to local and national economies. In the coming weeks, the focus will shift to testing and commissioning the equipment. Every valve, every sensor, and every connection will be scrutinized to ensure that the plant operates safely and efficiently. The meticulous work continues, with teams of specialists working round the clock to meet the tight deadlines. The completion of the C3 splitter installation is a moment of pride for everyone involved. From the engineers who designed it to the workers who assembled it, piece by piece, this achievement is a testament to their hard work and dedication. It's a reminder of what can be accomplished with teamwork, expertise, and a shared vision.
For 50 years, Crane Rental Corporation has been a leader in providing heavy hauling and lifting services across the United States. In 2011, they took on a challenging project to transport a cold box weighing 319,000 pounds and measuring 150 feet long, 19 feet wide, and 22 feet high. This cold box was critical for a state-of-the-art air separation facility in Central Florida designed to liquefy nitrogen, oxygen, and argon gas directly from the atmosphere for local businesses. The cold box was manufactured in Japan and delivered to a West Coast Florida port via a geared ocean-going vessel. Upon arrival, the ship's cranes transferred it onto an 18-axle dual-lane Goldhofer trailer from Crane Rental Corporation. The transport route presented several challenges due to multiple bridges with capacities insufficient to support the cold box's weight. To mitigate this, the Department of Transportation, DOT, required the load to be distributed across the four corners of the cold box. Crane Rental Corporation devised a plan to comply with DOT requirements and ensure safe passage. The cold box was transloaded from the initial 18-line dual-lane Goldhofer to four 6-axle Goldhofer trailers positioned at each corner. This configuration distributed the load and allowed the weight to be supported by multiple beams and columns during bridge crossings. Wide flange beams were strategically placed at both ends to facilitate these transfers. Metal stools were used to temporarily stage the cold box during trailer reconfigurations. Before any movement, a safety meeting was conducted with 64 participants, including local and state police, utility companies, and crane rental employees. The bridge was inspected by Richardson Engineering both before and after the crossing to ensure safety and structural integrity. The transport required different trailer configurations for various segments of the route. After each bridge crossing, the cold box was reloaded onto the 18-line configuration to navigate the roads and tight turns. The en route configuration changes posed additional challenges. The first bridge had limited space, necessitating trailer reconfiguration in the roadway and complete traffic blockage at 2 intersections. During the 12-minute crossing, the interstate highway below was cleared of traffic, with entrances blocked and a rolling police roadblock in place. While the interstate closure was brief, the roadway was closed for a 24-hour window. The second bridge presented a different scenario with no available real estate on the shoulder and no option for a 24-hour road closure. Crane Rental performed the swap at a nearby truck stop, staging the pre-configured Goldhofer trailers for the swap back. The load had to cross the median, facilitated by plastic mats and quick-working personnel. This process was efficient, but after crossing the second bridge, reconfiguring back to the 18-line trailer took 3 hours and required a large section of the 2-lane highway. Due to space constraints, the reconfiguration process required sequential steps. Metal stools were placed under wide flange beams to lower and remove the Goldhofer trailer from the cold box. The 18-line Goldhofer was then repositioned, and a 6-line self-propelled Goldhofer removed the large I-beam. The prime mover was reattached to the 18-line dual-lane Goldhofer. Several traffic lights and power lines needed raising due to the load's height. The length and width necessitated studies at each intersection to ensure safe turns. Police escorted the entire route, managing traffic as needed. Commuters were either inconvenienced by the slowdowns or amazed by the engineering feat. One turn required using a borrowed parking lot, protected with mats. At the job site, 2 hydraulic trucks lifted the cold box off the 18-line dual-lane Goldhofer onto stools where it was painted, and utility catwalks were installed. The job was executed flawlessly, with no accidents or property damage, maintaining Crane Rental Corporation's industry-low 6.9 EMR rating. This project showcased their expertise in heavy hauling, rigging, and crane operations. Using their 600-ton capacity Terex AC 500-2 crane, Crane Rental Corporation lifted a 58-ton Proton accelerator into the new cancer center at Orlando Health. This Proton accelerator, crucial for advanced cancer treatment, required precise planning and execution. The Terex AC 500-2 crane, renowned for its robustness and versatility, was the ideal choice for this critical lift. Its impressive lifting capacity and advanced engineering ensured the safe and efficient placement of the accelerator. The Maxim Crane Works, LP, and Crane Rental Corporation excel in handling overdimensional loads, as demonstrated by their recent project involving the transportation of 3 sections of a liquid natural gas, LNG tank, from Oklahoma to West Virginia. This massive undertaking covered nearly 8,000 miles and involved moving almost 700,000 pounds of cargo. The video footage from this project showcases the remarkable capabilities of the specialized equipment used. The hydraulic dual-lane trailer, a critical component of the transport, can be seen adjusting its configuration to navigate under an overpass. This feature ensures that even the tallest loads can safely pass through areas with height restrictions. Additionally, the separate remote control steerable dollies. These dollies allow the enormous load to make tight turns, demonstrating their precision and maneuverability. Transporting such large and heavy sections requires meticulous planning and execution. The teams at Maxim Crane Works and Crane Rental Corporation are experts in this field, ensuring that every aspect of the journey is carefully considered. From route planning to equipment selection and load securing, no detail is overlooked. The LNG tank sections themselves are crucial components for the energy sector, and their safe and efficient transport is essential. Maxim Crane Works and Crane Rental Corporation's ability to handle such a complex and demanding task underscores their industry-leading expertise and commitment to excellence. In this particular project, the challenges were manifold. Navigating nearly 8,000 miles with such a significant load involves crossing various terrains, adhering to multiple jurisdictions' regulations, and ensuring the structural integrity of both the cargo and the transport vehicles. The hydraulic, dual-lane trailer and remote control steerable dollies were indispensable in overcoming these challenges. This project is a testament to Maxim Crane Works and Crane Rental Corporation's proficiency in moving over-dimensional loads. Their advanced equipment, combined with their skilled team's expertise, ensures that even the most challenging transports are completed successfully. The safe and timely delivery of the LNG tank sections to West Virginia highlights their dedication to providing top-notch service in the heavy hauling industry. Maxim Crane Works, LP, is the leading coast-to-coast provider of crane rental and lifting services in the United States, renowned for its vast and diverse fleet. With a commitment to delivering exceptional lifting solutions, Maxim Crane Works offers a comprehensive range of equipment to meet various project needs. Their fleet includes everything from the versatile 8-ton carry deck cranes, which are perfect for maneuvering in tight spaces and handling smaller tasks, to the immense 2,535-ton capacity Manitowoc 31,000 crane, capable of undertaking some of the most challenging and substantial lifts in the industry. The company's extensive inventory of cranes and lifting equipment ensures that they can address any lifting requirement, whether it involves delicate, precise placements or the handling of oversized loads. Maxim Crane Works is equipped to serve a wide array of sectors, including construction, energy, and infrastructure, providing reliable and efficient solutions across diverse applications. Their state-of-the-art cranes are complemented by a team of highly skilled professionals who bring years of experience and expertise to every project. Maxim Crane Works prides itself on its ability to deliver safe and effective lifting solutions, leveraging advanced technology and rigorous safety protocols to ensure optimal performance and client satisfaction. Their commitment to excellence is evident in their track record of successfully managing both routine and extraordinary lifting tasks. By combining cutting-edge equipment with top-notch service, Maxim Crane Works has established itself as the premier choice for businesses across the country seeking dependable and innovative crane rental solutions. Whether handling routine maintenance or undertaking complex, high-capacity lifts, Maxim Crane Works remains at the forefront of the crane rental industry, setting the standard for excellence and reliability. We are undertaking the installation of a gigantic desulfurization plant at the headquarters of ArcelorMittal in Ghent, Belgium. This ambitious project is currently in its most challenging construction phase. Our goal is to integrate a state-of-the-art sulfur removal and recovery unit into the existing coke oven gas treatment plant. This advanced desulfurization facility will significantly enhance the efficiency and environmental sustainability of ArcelorMittal's operations. With meticulous planning and execution, we aim to deliver a cutting-edge solution that meets the highest standards of performance and reliability, contributing to the long-term success and innovation of ArcelorMittal. Cranes are indispensable in the construction industry, playing a critical role in lifting and moving massive and heavy materials that are essential for building complex structures. Their importance cannot be overstated, as they enable the efficient handling of oversized products, streamline construction processes, and enhance safety on job sites. At the heart of the construction industry's ability to manage large-scale projects is the crane's unique capability to lift and move significant loads that would otherwise be impossible to handle manually or with smaller machinery. From skyscrapers to bridges, cranes are used to lift beams, steel girders, prefabricated modules, and other substantial materials that form the backbone of modern infrastructure. Their sheer lifting power allows for the rapid assembly of structures, reducing construction time and costs, and contributing to the overall efficiency of building projects. One of the primary advantages of cranes is their ability to reach and operate in areas that are difficult to access. Tower cranes, for instance, are commonly used in high-rise construction, where their height and extendable arms enable them to lift materials to great heights and across large distances. This capability is crucial for the vertical construction of buildings, where materials need to be transported from ground level to the upper floors with precision and speed. Similarly, mobile cranes and rough terrain cranes offer versatility, as they can be moved from one location to another, providing flexibility for various types of construction work, including roadwork, bridge building, and site preparation. The design and engineering of cranes are tailored to handle specific types of loads and construction scenarios. For example, lattice boom cranes are ideal for heavy lifting in industrial settings, such as factories and power plants, due to their strength and stability. On the other hand, crawler cranes are equipped with tracks that allow them to traverse rough terrain, making them suitable for construction sites with challenging ground conditions. Each type of crane is engineered to meet the demands of different lifting tasks, ensuring that the right equipment is used for each job. Safety is another critical aspect where cranes contribute significantly. Construction sites are often hazardous environments with a multitude of risks, including the potential for falling objects and unstable loads. Cranes, equipped with advanced safety features and operated by skilled professionals, help mitigate these risks by ensuring that heavy materials are lifted and moved securely. Modern cranes are designed with sophisticated control systems, load monitoring, and stability mechanisms to prevent accidents and ensure precise handling of materials. The presence of cranes on site, therefore, enhances overall safety and reduces the likelihood of injuries and accidents. In addition to their functional benefits, cranes also contribute to the aesthetic and design aspects of construction projects. Their ability to lift and place large and intricate components allows architects and engineers to realize complex and innovative designs that would otherwise be challenging to achieve. From the iconic steel frameworks of skyscrapers to the intricate elements of large public infrastructure projects, cranes enable the construction of structures that are both functional and visually striking. Cranes also play a pivotal role in the assembly of prefabricated components, which are increasingly used in modern construction to improve efficiency and quality. Prefabrication involves manufacturing building elements off-site and then transporting them to the construction site for assembly. Cranes are essential in this process, as they lift and position these pre-built components with precision, ensuring that they are correctly aligned and securely attached. This method not only speeds up the construction process, but also enhances the quality and consistency of the final product. The versatility of cranes extends to their use in various sectors beyond traditional building projects. In industrial applications, cranes are employed to handle heavy machinery equipment, and materials in factories and warehouses. In the energy sector, they are used to install and maintain large components such as wind turbines and power plant boilers. In maritime and port operations, cranes facilitate the loading and unloading of cargo, including shipping containers and bulk materials. This wide-ranging applicability underscores the crane's integral role in modern infrastructure and industry. As construction projects become more ambitious and complex, the demand for advanced crane technology continues to grow. Innovations in crane design, including increased lifting capacities, enhanced maneuverability, and improved safety features, are continually evolving to meet the changing needs of the industry. The development of new crane models and technologies ensures that the construction industry can keep pace with the demands of contemporary projects, driving progress and enabling the construction of ever more impressive structures. In summary, cranes are essential to the construction industry, providing the lifting power and versatility needed to handle large and heavy materials. Their ability to operate in challenging conditions, enhance safety, and support complex designs makes them a cornerstone of modern construction practices. As the industry continues to advance, cranes will remain at the forefront, driving innovation and enabling the realization of ambitious architectural and engineering projects.